In our previous class, we have discussed about the momentum. In today's class, we'll be taking the Newton's second law, which states that when a force is applied on any object, it is directly proportional to the rate of change of momentum that is brought in that object. What does that mean? It means if an object of mass m is acted upon by a force capital F, an object of mass m is acted upon by a force capital F which is already moving with velocity small u. This mass m was moving with velocity small u. It is acted upon by external force capital F. After the application of force, the object changes its velocity to small v. The object which was previously moving velocity u has changed its velocity to small v when force F is applied on it. Now according to second law, this force is directly proportional to the change in momentum upon time in which we have brought that change. Force directly proportional to change in momentum upon the time in which that change has been brought up. So we can say F is proportional to P final minus P initial upon time taken. And if you remember, P was a denotation for momentum. Now in our case here, this F will be proportional to, what will be the final momentum? Mass is m, velocity is v. So momentum will be mv. And initial momentum will be mu. So mv minus mu divided by t. Simplifying it, we get mv minus u upon t. Now this v minus u upon t is your acceleration. So we can write it as F proportional to m into a. Now whenever we are removing a proportionality sign, a constant is being placed. So here F equal to kma. This F equal to kma is a relation for Newton's second law. Now this k is a proportionality constant. So we have to find out its value. So how we can do that? This k depends upon the values which we are taking and the definition which we are taking for the force. Let's say we are saying that force 1 Newton is defined when mass of 1 kilogram is accelerated for 1 meter per second square. Now what does that mean? It means F equal to K into 1 into 1. Since we have taken F as 1, so 1 equal to K. So the value of this proportionality constant comes out to be 1, and our relation is modified to F equal to ma. Now this F equal to ma is a relation for Newton's second law, which says that force is equivalent to the product of mass and acceleration. Okay, let's move further. Now from this, what we can conclude? We can say that if we can somehow manages to increase the time in which change has been brought up, then we can reduce the amount of force. So there are certain applications for this second law. What are those? Let's talk about the first one. When a cricketer catches the ball, a cricketer catches a ball. So what happens? As the cricketer catches the ball, he catches the ball and brings his hands down. So why he is doing that? Is there any help that he is getting from it? The answer is yes. What happens? Let's say a ball which is moving with velocity v. Now as the cricketer holds the ball, the velocity is 0. Right? The ball is coming with a certain velocity. After completing the catch, this velocity has to be 0. So if we talk about our relation, we have F equal to m v minus 0 upon t. Now what is this time t here is? Now time t is how much time you have taken to catch the ball, or simply how much follow through you have taken after catching the ball. If we increase the value of this time t, what will happen? This force will decrease. Correct? So more the time you are taking in taking the cash, the lesser impact you will be feeling in your hand. So this is the application of Newton's second law only. Let me explain it again. What has happened here is the cricketer who has caught the ball, while catching, what he has done is he has brought his hand down. Means increase the time in which the velocity has been reduced to 0. And since the time gap is increased, so the impact force has been reduced. Right? Let us talk about the second application. For second application, let's talk about the seat belts. Have you ever heard that for seat belts we can use the term safety belts as well? Why so? Seat belts or safety belts. Now, these seat belts or safety belts in your vehicle are truly your helping hand or your friend. They are saving you. How they are saving you? Let's say there is an impact. If there is an impact, what will happen? The car will just cease its motion and will come to rest. And it's not like the car was traveling at a speed of 10 km per hour, 20. We are expecting a speed of 60, 70, 80, even 100 km per hour. Now that speed is brought to rest after the impact. Now what is seat belt gonna do? What it will do is, it will just increase the time in which your body will come to rest. If you are not wearing the seat belt, the moment the car hit the obstacle, the car will cease its motion, it will come to rest. At the same time, your body will also come to rest. And since the time is being very small, the impact will be very large. Why? Again, from Newton's second law, that is F equal to mv minus u upon t. Again, the v is being 0 because we have brought the car to rest, and this time t factor, this will decide how much impact you will feel. More this time, lesser the force. That's why we say it is mandatory to wear the seat belts, because seat belts can even save your life at the time of accident. This is another practical application for Newton's second law. Is there any other application that you can think of? No? Okay, let me help you. There is one application that how the athletes take the high jump. You might have seen in your TV or somewhere else that when an athlete takes a high jump, he usually jumps onto a soft cushion. Means the cushion on which the athlete falls is generally a soft one, or even a sand also. Why so? Again, the same reason. Because again, there has the force of impact which the athlete will feel. His mass will remain the same. Velocity again will become 0 after the impact. Certain velocity with which he will fall, and again the time t. This time t factor again gonna decide what will be the impact force of the athlete, or how much impact he will feel once he hit the ground. If this time has been increased, so the force will be less. If this time is less, obviously the force will be more. So in case you falls onto a hard surface, then there is a very high possibility that you can even break your bones. At the same time, you are taking a high jump and you are falling onto a cushion, or you are falling onto a sand. Then of course, this time t will increase. And since the time t is being increased, so you will feel a lesser impact. So I hope this Newton's second law is clear now. So let's moving on. If I say the Newton's first law can be easily explained from this second law. You want to know how? See here. F equal to ma. This a can be reduced to v minus u upon t, or we can simply say mv minus mu upon t is equal to f, or ft is equal to mv minus mu. Now, just remember the Newton's first law. We have stated that when there is no external force, the object will continue in state of rest or motion. Come back here. We are saying that there is no external force. Means for our special case, this F has to be 0. Now since F is 0, 0 multiplied with any number, it will give you 0 result only. So we'll have 0 equivalent to mv minus mu. Just replacing the terms, we have mv equal to mu, cancelling out m, we get v equal to u. Now what does this v equal to u signifies here? It signifies with whatever state you are in, you will continue the same state. If you are at rest, if u is 0, v has to be 0 all the time. If u is certain number, v has to be that particular certain number only. Why? Because the object is in same state. That's what we can conclude it from Newton's second law. That's why we can say that also the Newton's first law is contained in the second law itself. This was all about Newton's second law. Now let's just try to solve certain numericals based on Newton's second law. Look, let's say there's an object of certain mass, let it be mass 2 kg. Okay, so we have an object of mass 2 kg is acted upon by certain force, let's say 20 Newton. You are supposed to find how much distance this object will cover if it is started from rest after 10 seconds. That's your question. You can just pause the video here and try to solve the question if you can do it. So mass is 2 kg, force is 20, time is 10 seconds, distance you are supposed to find. So very first thing that you will do here is just find out the acceleration. What is the acceleration? F equal to ma. So ma, F is how much? 20. So 20 equivalent to 2 into acceleration a, which we want to find. So 20 upon 2 gives us a. Simplifying it, we get a equal to 10 meter per second square. So that is the value of acceleration here. So we got the value of acceleration. Now we can easily find out the value of distance. How we can do it? Just place the values. S is ut plus half at square. And the question itself, it was mentioned that the object is started from rest. So initially it was at rest. So ut factor will be 0 plus half. Acceleration is how much? 10. We have just calculated. And time is again 10. So 10 square will be 100. 2 times 5 is 10. So 100 into 5, that gives us 500 meters. So this will be the displacement here. I hope this question was quite helpful. Now just try to solve another question. See, the question is, let's say the object is initially moving this time with a velocity of 60 meter per second. Okay, and there is a force of friction which is acting on the object, that is, let's say 10 Newton. And the mass of the object is, let's say 2 kg. This force is frictional force. And if you remember, force of friction always opposes the motion. What we are supposed to calculate here is how much distance will be covered till the object is brought to rest. So let's try to solve it. Again, you can do the same thing, just pause the video and try to do on your own. So here we have F 10 Newton. So let's find out the acceleration first. F equal to ma. F is 10, m is 2, acceleration we have to find, a comes out to be 5. Now since this acceleration is because of the force of friction, so this has to be negative. That's true. So now the next part of the question will be finding out the distance. So what you can do now, just apply the second equation, s equal to ut plus half at square, but we don't know the time this time. So what you can do is just go with the third one, v square minus u square equal to 2as. Now this is, you have to identify that which equation gonna give you the result, right? So here just applying the equation, v square, final velocity has to be 0, u is 60, 60 into 60 will be 3600, equivalent to 2, acceleration is how much? That was minus 5, and distance we are supposed to find. So this minus sign, cancel out. 2 into 5, 10, it cancel out 1, 0. Distance comes out to be 360 meters. So this will be the distance this object gonna cover before it comes to rest. This was all about Newton's second law. I hope the concept is clear, and the next video will be discussing about Newton's third law and its application. In the meantime, just go through the videos again, do revise from the books as well. We'll see you in next class.